Well, hello everyone, and welcome to the July 2023 edition of the St. Louis Java Users Group. For those who don't know, the St. Louis Java Users Group is an informal group. Attendance is free. We don't maintain a formal membership list. Normally, we meet on the second Thursday of every month except December, when there is no meeting. There's just too many things happening over the holidays for us to be able to organize a meeting in December. When we meet in person, you can join us for food and social at 6 p.m. and the presentations will start at 6:30 p.m. When we do meet in person, our normal meeting location is the Object Computing Incorporated training room, and that's at 12,140 Woodcrest Executive Drive, Suite 310, and that's in St. Louis, Missouri. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Alspaugh, that's me in the middle, Weiqi Gao, and Kathy Zwang. You can reach all of us at the St. Louis Java Users Group Steering Committee if you just send an email to that address that's at the bottom of your screen there. That's JavaSIG@ociweb.com. And if you send an email there, all of us will get that. I'd like to extend a welcome to the newest member of our steering committee, and that's Robert Levitt. So welcome, Robert. The St. Louis Java Users Group would not be possible without the support of our sponsors. So I've got the logos up here. So from left to right, top to bottom, we have Object Computing Incorporated. They are our original founding sponsor that goes back to 1997. And they've filled in so many different ways over the years. They supplied the training room when we were meeting in person and lots of things to be able to make the group possible. They've been with us all the way. JFrog is another very important sponsor. They sponsor the cost for the Zoom subscription, which makes the remote meetings possible, but they also cover the fees to create the Meetup website so that we can have a page on meetup.com. It's free for you to be able to attend a meeting, but it does cost the jug some money to be able to have a page on the meetup.com website. And JFrog covers that cost, and sometimes they'll come in and they'll throw some prizes in for the raffle as well. Signature Consultants and Adaptive Solutions Group are both headhunters. And when we were meeting in person, they would sponsor the pizza, but unfortunately, we still haven't figured out a way to send pizza over the internet. But if you're looking for a Java developer, or if you'd like to hire a Java developer, just do a quick Google search and look up Signature Consultants or Adaptive Solutions Group and let them know that you found out about them through the St. Louis Java Users Group. At the end of this meeting, we will be raffling 2 JetBrains licenses. Now, you must be present to win the JetBrains licenses at the end of the meeting. So I'm sorry if you're watching the recording, you're too late. You do have to be present to win those JetBrains licenses, and that will take place after tonight's presentation. Elastic has also sponsored gift cards for us, and we'll get those going when we're back to in-person. Intertech is a training company. So if you're looking for to learn Java or any other type of computing skills, look up intertech.com, and they've got lots of training videos. They sponsor the famous Screaming Flying Monkeys. What? Screaming Flying Monkeys? Well, they're little dolls, and if you throw them up against the wall, they scream and make some noise. They're a lot of fun. But they also sponsor coffee cups, mouse pads, and the like. And they've been a great sponsor as well. Now, at the end of the meeting, we will be also raffling 2 Manning ebooks of your choice. And once again, that will be at the raffle at the end of the meeting, and you must be present to win. those. So if you're watching the recording, sorry, it's too late. You do have to be present to win the Manning ebooks. Pearson is a sponsor of Computer Books, and they've been a great sponsor here as well. So thank you to all of our sponsors. As far as announcements go, the Strange Loop 2023 conference is coming up. That'll be at the St. Louis Union Station, September 21st through the 22nd. You can get the details about that conference if you go to that website that's on the screen there, thestrangeloop, all spelled out, .com, thestrangeloop.com. As far as upcoming presentations go, on August 10th, we actually have 2 Kotlin presentations scheduled back to back. First will be, and it's by the same person, John Burns at Grubhub. He'll be doing an introduction to Kotlin for Java developers for about 30 minutes. And then the rest of the meeting will be on the functional features of Kotlin. So the first is kind of a warm-up, and then the functional Kotlin is more in-depth. So that one I'm really looking forward to. And then on September 14th, we have scheduled GraphQL from the ground up, and that's by Jason Clark of New Relic. So if you'd like to keep up with our presentation schedule, it's easy. Just go to the meetup.com/gatewayjug website. And as presentations are scheduled, we just update the meetup site. And as soon as those are posted, it's okay. You can go ahead and RSVP for the meeting. Now, if you're interested in giving a presentation or becoming a Jug sponsor, that's easy. You can just email us at that address that I mentioned before that goes to all of the members of the steering committee. And that's that email address, javasigsc@ociweb.com. So those are my announcements. Tonight's presentation will be by Frank Greco from the New York JavaSIG, and he'll be talking about patterns, predictions, and programming. So what I'm going to do is I'm going to stop sharing my screen, and then that will enable Frank to be able to schedule his. So Frank, would you like to take it over?
There. Okay, now hopefully you can see my screen. I'll put it in the. Let me know if that's good. Now,
yeah, you're looking good there, Frank.
Unfortunately, when I'm full screen, I cannot see the chat window. So if you gentlemen could just let me know if there's a question there that I can pause and answer.
Okay.
So hi everybody. Happy July. So today we're going to talk about machine learning, but I titled it Patterns, Predictions, and Programming. It's essentially how machine learning is going to change your lives as programmers. So it's pretty cool, actually. You know, like as a technologist, usually you have to, like a surfer, right? You're in the water, you're looking to ride a wave. It's like, okay, there's a small wave, there's another small wave, here comes the big wave. And you saw like there's Web3 and there's crypto and there's this and that. Again, then you see machine learning is holy mackerel. That's the wave I want to ride. That's the big wave, right? So that's what we're going to talk about. So here's our little agenda. We'll get a little background on machine learning. Probably some of you are not aware what exactly is machine learning. I mean, you may have played around with ChatGPT and Bard and things like that, but what exactly is it? And how does the Java developer play around with this stuff, right? Because we can't let the Python programmers have all the fun. And then we'll talk about hopefully I have some time. I'll show some IntelliJ demos with the Java API to ChatGPT, and talk about the VisRec, visual recognition API, that my colleague Zoran and I have completed. And the last thing is, how does this affect developers? Okay, so let's take a step back and let's talk about patterns. So this gentleman way back in the 40s, right? This is a long time ago. He said that one of the most interesting aspects of the world is that it's considered to be made up of patterns. And he's 100% right. the only thing that I've changed, I would say one of the most interesting aspects of the universe is that it's all about patterns. Everything is about patterns. So that was quite prescient back in the 40s, right? This was not just a few years ago. This was back in the 40s. Now, some of you know that I'm a musician, and I've been a musician for most of my life. And my colleague Zoran, with the other co-author of our JSR, he's also a musician. And we're very familiar with patterns. And some of you may be musicians and you're familiar with patterns. So if I tell you that we're going to play a blues song and we're going to tell you that it's a 1-4-5 in the key of A, immediately you know how to play that. And if you're a jazz guitarist, I said we're going to do 2-5-1 in A minor. Immediately you know how to play because there's a pattern, right? And then also in music, there's melodic patterns, right? There's all kinds of patterns in music. And way back in a distant time in a faraway galaxy, I worked on generative AI, my master's project way back when. And what I did is that I looked at patterns in music and I looked at melodic patterns of a certain artist. And then I generated a new melody, but in that style. So that was my master's project. So I built, this big tree of probabilities, this big data structure of probabilities. So I analyzed the notes and the patterns and the sequences of notes, and I built a big tree where each node was a set of probabilities. And then I said, okay, now I want to generate a new melody. So traverse a tree based upon a random number generator. Actually, it had a fractal envelope to the random number, and then generated a new melody. That was generative AI. We're talking back, this is back in the 80s I did this. So this is also something that's not new, yet we hear about generative AI today, right? So I also worked on Wall Street, and I worked for the New York Stock Exchange in the late 80s, and we were looking for the bad guys. We were looking for people that were trading on illegal information. So we looked for patterns, right? For trading patterns that were a little shady, and sometimes we looked at, were the patterns related to where a trader lived, right? Is it related to zip codes? So we did a lot of statistical analysis on this, but we were looking on illegal trading patterns. That's the key word. And then later on, I worked at Lehman Brothers, and we were working on portfolio management systems. And our goal was that we were looking at patterns in a portfolio because our clients wanted to know, why did their portfolio go up? Why did their portfolio go down? So we had to investigate patterns. And we tried to find a reason why their portfolio went up and down, a real reason, like a real causal, causality. But we sort of honestly, we BS'd them a little bit. We said, well, we knew it because your IBM stock or your Microsoft stock went this way or that way. But that's not a reason. That's just part of your portfolio went up or down. That's not the real reason why. Well, what happened with Microsoft? Why did that affect this other thing? Why did the IBM stock affect the Sun Microsoft stock? So we really never found it, but we were looking for a pattern. So we all know about patterns, and certainly this book should be very, very familiar to all of us, right? And this is back in the mid 90s, right when the internet and the web were starting to come out in the enterprise. And this book was about patterns. Now, what's the interesting thing about this book is that this book was patterned on a talk that that Kent Beck and Ward Cunningham gave at a conference, at an OOPSLA conference, on using pattern languages for OOP. So this book was patterned on a talk about pattern languages. So also, what was that based on? So if we go back further in the 70s, well, that talk and those pattern languages were based upon this book. This book was called A Pattern Language. It had nothing to do with software. It had absolutely nothing to do with software. It was about buildings and construction, physical buildings. So this book influenced pattern languages, which influenced the talk and it influenced the book on patterns. So there's patterns based upon patterns based upon patterns. And this book influenced the development of Agile. So this is really interesting. So, and those concepts were based on patterns in buildings from centuries ago. So next time you have a decorator pattern, or a visitor pattern in your code, it's coming from someone that lived back in pre-dawn time. So this is not something that's new. It's something that we've sort of recognized over a long, long time. But the key word here is pattern. And of course, as programmers, we deal with regular expressions. So what are regular expressions? Those are text patterns, right? We use them in our Java code all the time. We use them in our shell scripts all the time, right? We use them in many other languages. So regular expressions are describing patterns in text. And there's that key word again. And the interesting thing about regex, right? So, back in the 40s, artificial neural networks, the basis of all AI these days, that was invented back in 1943. Actually, you can probably even go back into the 30s when mathematical biology first came out in the 30s. But 1943 is when they first created artificial neural networks. And of course, we know that's the basis of ChatGPT and Bard and everything at this point. But the interesting thing is in the early 50s, regular expressions, so Stephen Klein, Professor Klein, invented regular expressions in 1951 to experiment with neural networks. He created regular expressions to experiment with machine learning. That's why regular expressions were created. But of course, we use them all the time to figure out if a bit of text is a legal email format or a legal URL. But if you look at it, if you follow the history, he developed regular expressions to look at text patterns. That's quite interesting. So patterns are all around us. They're in music, they're in nature. I mean, the bears know about trout patterns and how to catch their food. Of course, in finance, I worked on Wall Street. The patterns are all over the place. I was also an astrophysics undergrad for a short period of time, and cosmology has patterns everywhere. And how stars behave, how stars grow, no supernova, they're all patterns. And I so often look at supernova and compare that to music. And I say, like, well, there's a pattern. So cosmology shows us a pattern, but music has patterns. Are there similarities? And you could think like, well, it's like supernova patterns. So a star becomes, it kind of pulsates because it becomes complex, complicated, right? It becomes a big gas and the mass just starts to pulsate. So that's increased complexity. And we know about when we build systems, there's increased complexity, right? And sometimes it gets so complex, it gets too unstable and it blows up. And we have to start from scratch because it's hard to debug, it's hard to maintain. So, it's interesting that potentially there's a relationship between the chaos of a supernova and software, and even music. And why were the Beatles popular, and why was Elvis popular? So they all followed a period of instability. So I thought, like, what? There's patterns, there's music patterns, there's cosmology patterns, there's software patterns, there's business patterns, there's finance patterns, there's nature patterns, there's innovation patterns, there's even patterns in sports, right? If we know the patterns of our opponent, like whether it's in football, right, American football, or it's in European football where they actually use their feet, unlike us. So there's patterns. So I always found this fascinating, patterns. Now here's another interesting thing. So here's on the left, we have a map of France, right? And there's the network, the communication network, or actually I think it's a train network. Somebody said, like, you know what, I'm studying these one cell organisms called slimes. And I'm going to try something. So they created a map of fronts, and they put, I think slimes are very fond of oatmeal. So they put proportional amount of oatmeal based on where the cities were on the map. And lo and behold, a one-celled organism duplicated what intelligent human beings did in a train system. The network matched. So first of all, it's telling us, well, maybe we're not so smart after all. But it's telling us that there are patterns. There are patterns. Maybe we're just like, we think we're so far ahead of everything, but maybe there are fundamental patterns to things that we're unaware of. So this was all fascinating to me. And of course, and then slimes don't move too slowly. So I mean, you can Google for a video on slime mold and how it duplicates network patterns. This is taken over a period of several hours, but it's pretty cool. So machine learning is all about patterns, right? So we read about machine learning every day. I mean, every day there's something new in machine learning, generative AI. It's all about patterns. So it's about recognizing patterns in a data set, right? So you look through a giant data set, and then you find patterns, and then you predict or you generate, right? Either you predict what's going to happen or you generate the thing that's going to happen based upon the patterns that you recognize. So here's a little graph that I put together just to make it clear, because this gets confused, and the average person that's not a tech person gets all kinds of, they don't understand what this is. So this is for us, the smart people in the room. So AI is this big thing. It's the simulation of human intelligence. I mean, whether we're really intelligent or not, that's another story, but it's simulating human intelligence. So machine learning, of course, artificial intelligence is not something new. I mean, in the 80s, expert systems were really popular, and symbolic AI and linear programming have been around for decades. Machine learning is a type. It's a type of artificial intelligence. And when the word learning, right, it learns about patterns. So machine learning is about pattern recognition. So that's a subset of AI. Deep learning it's a subset of machine learning, but it uses neural networks and sophisticated algorithms, and it uses cloud computing, and it uses GPUs. So it's a more intense machine learning. And then with deep learning, which uses neural networks, there's two basic types. There's generative and there's predictive. Okay, so nowadays when we're talking about ChatGPT and Bard and stable diffusion and all kinds of things, those are predictive. Oh, pardon me, that's generative. That's generative. There's also predictive, right? Like predicting the weather. That's not generative. We're not generating the weather. We're predicting the weather. So that's predictive. But generative has sort of caught the eye of everybody these days because it has a lot to do with text and images. So of course, we're humans. We like text and images. So it's popular. But also predictive is still quite popular in many use cases. But that's the specifics. But in the average magazine article, you'll hear about AI, and they talk about ChatGPT. But we're smart people in the room, so we understand it's the generative deep learning subclass of machine learning, subclass of AI. That's what it really is. But people call it AI. Just want you to be aware of that. Okay, now this is way different from what we do in programming. Way different. So on the top here, that's the way we've been doing programming for decades. We have data, we have a data store, we have something in our head that we, our model or programming model, we write a program, write a Java program, and we get a result. Pretty traditional. Machine learning is different. So machine learning is that you have the result and you have the data, and you're asking the machine that with this data, I want to get this result. What is the model that will generate that result? What is the model? So we're asking the machine to give us essentially the program that generates the result. So it's a little different. But with machine learning, there's two phases excuse me, there's two phases. There's excuse me, there's training, and then there's inference. Sorry about that. So there's training and there's inference. Now with Java, we know that there are many Java APIs, and we can't let Java people have all the fun. So years ago, Zoran Savaritz, Java champion, and I, we started JSR to have a Java API. And the reason why we did that is that we didn't want another doomsday scenario. And so what I mean by that is that with JavaScript, we have the web, which is, you know, one of the greatest things for mankind. How many languages can we program the web? Well, one. That's not a good thing. We have, it's like if you're in a band, a music band, and you have a bass player and a sax player and a drummer and a guitarist and a singer, and you say like, okay, here's a kazoo. Everybody gets a kazoo, and you have to create good music out of it. Well, you can create music, but it's difficult. So this is not so much a dig at JavaScript, it's a dig at having one language to develop everything. So Python is a good language, but it can't be the only language, because there's too many people that there's too many other languages that can leverage programmers' creativity. Okay, so what we did is that we came up with a Java API based upon our conversations with many other organizations of all these people here. JSR 381. So JSR 381 is visual recognition for Java. And there's a link. How many people have seen this before? Hopefully a few. Now, it was designed so that it was a standard Java API for visual recognition, for computer vision. Now, the reason why we did this is that there are existing APIs, but they assume that you have to know C language because there's a lot of interaction with the low-level machine APIs. So we wanted something that was the average Java developer would be familiar with. So that's why we developed JSR 381. And that's the architecture. So the orange part is that's the public API. And inside JSR, we have a generic machine learning layer, and we just have a visual recognition layer on top of that. But the API can do generic ML things like create different models. But it's specifically the API, the public APIs for visual recognition. And we've had many people use it and say that it's, for the first time, it's a bona fide Java API. Now there's if you want to take a screen snap of this, that's where the reference implementation is. So like all, I'm not sure why I'm losing my voice all of a sudden, but this is the implementation. All JSRs are APIs. They're not implementations, they're APIs. But part of the JSR process is that you have to offer an implementation. So we use the DeepNets Community Edition to implement the API. And so it's one possible implementation. Amazon took our API and they implemented using their DJL. And there's an InfoQ article on that. Okay. Let me see if I can show a quick demo. is it not showing my, oh, it's underneath here. So let me show you a few slides, and now I'll jump to the demo. So what this demo is showing is that it's the process, the workflow for machine learning is that there's data prep where you make sure that you have clean data, and you train a model, and you test the model, and then you do predictions, or you generate new data. Now, if this was drawn to scale, data prep would be the size of my house. You know, this is not drawn to scale. So the hardest part is the data prep. Of course, the sexy part's the stuff in the middle. Like this is everyone's playing with this stuff in the middle. But the hard part is actually making sure the data is clean and there's no bias and there's no outliers, things like that. Oops. Okay, so I'll run through this real quick, but I want to show you the demo. So I took a database or data set of chihuahuas, specifically of light colored chihuahuas, and it was only 872 images, which is not a lot of images. And there's a data set I took them from, and I used our JSR to create a model. Right, since the model is just a binary file. And the way you do that is just basically one line in our JSR. It's uses a builder pattern. There's your image classifier. There's the height and width of the image. Where exactly is the file where the images are identified? In other words, their paths. There's where they want to save the model. How intense? How long do you want to train it? You know, if you can say just train it for a little bit and give me a model, you're not going to get good accuracy. If you say, you know, train it, give it a lot of epochs and reduce the error to like close to 0, it may run for many hours. Okay, so once we have the model, we have some new images, and here I have 3 other light colored chihuahuas, and I also have a mushroom. Now I didn't train it on mushrooms, I trained it on light colored chihuahuas. So here's the code that says create a classifier. Here's my images, the models in that file, make some predictions. And here are those files that I'm testing against. And it says that the first one, that's 88% a Chihuahua. The second one is 88.68% a Chihuahua. The third one, the mushroom, says it's 66% of mushroom, a Chihuahua, which is not that good. And the last one says it's 87.8% of Chihuahua. So those that are probabilities, and now I could let me run this thing. So this is the same code. It's probably using a more up-to-date version of our library. Right, here's a classifications here, and so I ran this earlier, so I think Zoran updated our library, so it's even giving better results. Actually, I think Zoran made some significant strides in performance. So I mean, we're getting really high marks. But it's also saying the mushroom is 64.6% of Chihuahua, which is not that good. So what is this telling us? Okay, it's telling us that I don't have enough data. It's saying that while it's accurate for light colored Chihuahuas, I didn't try any dark colored Chihuahuas, which are light colored Chihuahuas. It's saying I don't have enough data. So this was a program that I ran one of the first times I ran our JSR, and then Zoran, my colleague, being the ML researcher, he told me, he's like, you don't have enough information. A mushroom shouldn't give you 67%. That's worse than flipping a coin. So that's certainly not good. So it tells me that you need way more than 672 images. So the more images you have, the more data you have to train your model, the better off you are. So that was informative, quite informative. And I didn't train it for mushrooms, I trained it for light colored Chihuahua. So that was eye-opening for me many years ago. So you can screen snap that or set your mobile phones to that to get how to get started. It's actually pretty cool. It's a lot of fun, actually. I mean, and it's a real Java API. It's not like a C library, a C API. You have to send 25, parameters to a function call. It's not like that. It's a real Java API. I mean, we're both Java champions. We wanted to have a real Java API. Even though in my past I've been a C programmer, I wanted a Java API for people to feel comfortable. So it's very easy to use. And there's another, you can screen snap this to get a bunch of helpful URLs. So that's RJSR, and it's a lot of fun. I would suggest you try it. I mean, it's just you get so deep into it, you spend hours with it. So it's a lot of fun. So that's also predictive. That's predictive AI. So now we're talking about generative AI. So this is what everyone's talking about. Everybody's been talking about this, for a while now. ChatGPT, bars, stable diffusion, all these tools. Okay. So what do you think is the fastest growing programming language for 2023? Okay, well, I can see if I can open the chat window. Oh, I can't open the chat window. It's a floating window. I think you probably can see that. I think you can see that screen. Python. Ruby. Okay, it's a Ruby person. Okay, well, someone says Java. Yay, Java. Okay, so I'm going to hold off on answering that. But here's a Java developer over here who was saying, like, what? Are you kidding me? You can't possibly be that. So well, let's continue now, and I'll answer that. Okay, so ML, ML's been around for a while, and it's before 2017, there's all kinds of interesting things, but progress wasn't like it is today, right? Progress is like, if you don't follow ML on a daily basis, you're behind in one day. There are things that are happening. It's just the cool thing about it. This is like, when the web first came out, it's like, holy cow, did you see this? Did you see that? Did you see this? There's a lot of interesting things. But in 2017, at the end of the year, December 6th, Google and a bunch of other researchers came up with a paper called "Attention is All You Need." And in there, they described a new architecture for machine learning, for text, for language. And instead of looking at streams of words and figuring out probabilities, what would be the next probable word, and what's the next probable word, they didn't do that. They sort of like, well, you can do that because every word, it's not just like every word has the same attention, right? It doesn't have the same weight. Some words have more weight than others because they may refer to words before. So that's what I call attention is all you need. So they came up with an algorithm that gave weights attention to various words. And the second thing that this architecture added was prior to this paper, when you trained a machine learning program, you had to take in all the data, and you had to wait to process all the data through your neural network. This massive network of neural nets, and you had to wait for the whole thing to complete. Now we know as Java developers, when problem like that, we often think of threading, right, to solve that. And so the transformer architecture is parallelizable. That was another huge advantage to this. So now you can train something using many threads, many paths. So it made training so much easier. So that was a huge advantage. So now after 2017, and now in 2023, we're getting so many things that are happening on a regular basis. I mean, ChatGPT, a year and a half ago. Now there's even more advances based upon this architecture that things run in your desktop, not even in the cloud. So this paper is one of those papers that, when you go to school and you read about the history of computer science, this is one of those papers. It's the transformer architecture. And I thought I put the URL someplace. It's hidden by Zoom. There's a question in the chat. There's a comment on Fruppy. That's a good comment. Okay. So there's just a quick set of definitions. We know what a model is. It's just it's basically a model is a file, right? It's an entity. It's a file. It's a large data structure that's persistent, and it's been trained to recognize patterns. And it's just basically it's a binary file. We have LLMs, right? Large language models, and those are models based upon text, about language, whether it's English or some other speaking language. It's about text. And generative AI, which I talked about before, there's predictive ML and there's generative ML. There's the regular press calls it AI. It's generative AI. There's predictive AI. It's been around for a long time. Right. And we know about ChatGPT, from OpenAI.com, and Microsoft is a huge investor in OpenAI. And I think over the past few days, Mr. Elon Musk has his own company, because he was one of the original founders of OpenAI way back when. He wanted it to be an open source company. So it started off as open source, but they decided to make it closed source. And so he left. He didn't want to be part of that. So now he started his own company to compete with OpenAI. Even though he's told people we should wait 6 months on development AI, but that's Elon Musk. So OpenAI has a bunch of services, right? And the heart of OpenAI and ChatGPT, GBT is generative pre-trained transformer. So it's a transformer architecture. And it's generative AI. So we learned about generative AI. We know what transformer is, and it's pre-trained. So it's a bunch of pre-trained transformers there for various things. And the one thing that it's based on is text, language, large language models. So they're pre-trained transformers based upon language. So that's what GBT stands for. It's funny, sometimes you watch the news, regular news, and the newscasters talk about GBT as if they know what it means. It sounds cool, GBT. And ChatGPT, okay, and ChatGPT is the web app, right? So OpenAI has a bunch of services, and there's REST APIs for that. So the ChatGPT app is a web app that talks to their server. So that's what that is. And they have a DALL-E, which does images, and they have Whisper, which kind of makes sense because if we're talking about languages, well, it'd be nice if we can convert voice to text to then send to ChatGPT. So it didn't make, it wasn't a surprise to have an API for voice to text. So I kind of put this together. So there's a bunch of APIs. There's actually another new API they created recently about adding your own function calls into this stuff, but that's for another talk. So they're basic services to complete text. So you say, like, here's some words, and based upon what you understand as probable next words, complete it for me. So there's something for chat. There's something for generalized text completion. There's now a lot of completion for programming code, and it's getting quite good. There's one for images. There's Whisper for text. Now these two down below are very interesting. So there's the user interface, right? The ChatGPT and just using it for kind of fun stuff. But the two things at the bottom. So these are quite interesting because this is how you create either your own model, like a fine-tuned model is a model that sits on top of the foundational ChatGPT or Bard or whatever other company, Anthropic, all these other models. It's your own model. Like if you have your own set of text, let's say you work for a company and you have a lot of documentation, it'd be nice to have a chatbot interface to this. There's one way of doing it is creating your own model, a fine-tuned model. And there's another way of using embeddings, and I'll talk about that because that's the really cool part, in my opinion, of all this. Yes, there's classification and generalizing and all sorts of good stuff, but the two bottom things is that's the cool stuff. And I'll talk about that in more detail. Right, and here's the web app. So OpenAI went out prior to 2021, and they looked at Wikipedia, they looked at GitHub and the New York Times. They went out all over the internet and, tons of information, and they trained their LLM, they trained their large language model on data prior to September 2021. So, and when they say trained on the patterns, the language patterns, not so much the information, but the language patterns. Remember, so we're the smart people in the world. This is how it works. It's about text patterns, right? It's about text patterns. It's not about information. It's about text patterns, right? So remember that. It's really, really, really important. It's not really a search tool. It's a text tool. And I'll talk about that more detail. Yeah, so we certainly know what web apps are. So ChatGPT, when you type in, I think it's chat.openai.com, that's their web app. Now, I wanted to program OpenAI, and I wanted to use it in Java, right? That's the first thing we want to do. I want to program this in Java, and I didn't want to learn Python. Not that Python's a bad language, it's a great language, right? It's a great language for certain things, right? It's just like JavaScript is great for certain things, but not everything, right? You have to use the right tool for the right job. But I wanted to learn how to use it. So my usual pattern is that I like to create a curl script, when I'm learning a REST API, a little curl script just to see how it works. The rest is academic. If I can do it through a curl script, then I can do it through Java. So what I did is that I created this little shell script, curl. Here's their API. Here's some parameters you have to send it. You have to send it up, obviously, an API key. So you have to go to OpenAI, register for a key. They send you a link so you can go into your account. You create a key, and that's the key. I just have this foo thing, but you put your key in there. Now, I wouldn't put it in the script. I put it, you retrieve it from some other mechanism, but you could put it there. And then you send it this curl script. But the cool thing is that this -d, you send this, here's like this data that you're sending the REST API. It's like a language. It's like, well, the model I want the certain GPT model. This one's called 3.5 Turbo. And I checked earlier today, I think there's like 60 models that you can use. Some of them are beta, but they have 60 different models. ChatGPT 4, 3.5, there's DaVinci, they're all different models, and they all have different prices, by the way. The most expensive is ChatGPT 4. It's not cheap. So if you're doing development, pick like something like 3.5. Like I was doing hours of development with this model, ChatGPT 3.5 Turbo. I was doing hours and hours for a couple of weeks, and it cost me like $1. Less than $1. So it's dirt cheap. And then you send it this language, what the content is. And here I'm asking it, what is the joke of the day? And it comes back with this. So I wrote a little script that, this is my script. And I just piped it into this JSON pretty printer, right? The JQ is we all know it's a bash level pretty printer, and it tells us, okay, here's all your JSON, blah, 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 blah. And here the assistant, which is ChatGPT, in other words, the service. And it says, why did the tomato turn red? Because it's soy salad dressing. Okay, that's the joke of the day. But that was the completion. All right, so here's my script, and it came back. And so the next thing I said, well, let me reproduce the ChatGPT interface as much as possible, and I can do it in like an hour. So here's a little bash script that did curl at the bottom, and I piped it through this pretty printer. And I had basically the poor man's version of ChatGPT. So I type in hello, tell me a joke, what's a good word to talk. So give me an email template. So it's basically a poor man's version of the interface. Now, what's interesting about this thing is that you send to this text tool. So remember, it's a text tool. It is not a search tool. It is a text tool. You're saying like, here is context. Here are some examples. Here's what I want. And I'm going to give you as much detail as possible. Given this, I'm going to prompt you with this. It's like, this is basically what I want. I want you to complete it for me. Right? So think of those words. I have this text. I want you, here's a context. Here's what I really want. Here's some information. Here's the prompt. I'm going to prompt this tool, this text tool, and I want you to complete it. So ChatGPT says, okay. And it comes back with a stand-up comedian that kind of trashes Java. It was kind of funny, actually. So it's completing something that I started. In other words, I prompted it. I said, like, well, this is sort of what I want. I want you to complete it. So those words, prompt and completion. But it's just some interesting things that I can do. So I said, like, I want you to develop a sci-fi script that is a conversation. So I gave it a scenario in 2040, and there's an Italian boy and vacationing and using a quadcopter, blah, blah, blah. And it came back with like this really, actually, it was kind of a cool short story. And it kept on going on and on and on. And I said, this is almost like a little screenplay. So what it's doing is looking at probable words, right, based upon the transformer architecture, and just completing what I started. I prompted it and it completed. Again, it's not a search tool. People get confused, right? The average person says, well, I said, like, what is this? And it gave me the wrong answer. It's not a search tool. Search is a search tool. Google search is a search tool. This is a text tool. Okay. And it has a nice set of APIs. So there's this URL for the API. So, and it's quite simple. So that's and there's a Python library that wraps their REST interface. They don't have any other language, but so they rely on the community to build different language bindings. So there's a whole bunch of other language bindings for all kinds of languages, for C and for Ruby, for Go, for all their languages. And there was a couple of them for Java. I think they list one for Java, but if you go to GitHub, there's so many of them on GitHub. So I want to reinforce this. So a large language model, it's not really a search tool. It's a text pattern recognizer and text completion tool. So when you watch these shows, like 60 Minutes, the thing on ChatGPT, and you're saying, like, look, it's giving me the wrong answer. I'm searching for something. He said, well, it's not a search tool. If you're using it as a search tool and you get a wrong answer, who's at fault? The human is. So when you watch 60 Minutes, you sort of kind of laugh at these people. So this is like, it's sensationalism. It's just not, it's not a search tool. It's a text pattern recognizer and text completion tool. That's why it's called completions. And that's why they're called prompts. You give it like, here's sort of what I want, and I want you to behave like this, and here's the data, and I want you to complete this for me. So I'm prompting you and completing. So you train it, right? I mean, of course, OpenAI has spent a lot of money training their LLM, but then you could also further train it using your prompts, and then you ask it to complete it based upon your prompt. So notice those terms: complete, or completion, and prompt. That's where they come from. Oops. Okay, now let's talk about the Java API, finally. Okay, so the first thing, I mean, I tried to do this myself. I tried to write my own Java wrapper around the REST API, and it worked quite well for, which model was it? It was 3.0. So it was not ChatGPT 4, but it was 3.0. And I was actually surprised that, oh, I got it first crack. everything worked fine. Oh, this is pretty easy. And then they came out with 3.5 and all my code broke. And I realized that I realized two things. That they were changing their language. You know, there's a language that you send to them. They were changing that language based when they had an updated model. It's like, oh my gosh, why would you do that? So they weren't good at evolving their API. So all my code broke, and it's like, I'm going to redo this whole thing for a different model. So I sort of like got, I'll wait till somebody comes up with a library and I'll use that. So starting with 3.5, they got better with that. So it's it doesn't crash. And now I'm using different libraries. That was the first thing that was a revelation to me. The second thing is that when you design your prompt for a model, each model behaves slightly differently. So the stuff that you had for one model, like your fancy prompt that you spent like maybe an hour trying to get it right, when you move to another model, there's different behavior. So what you learn with prompting for one model may not port to the next model. So there's something for you to be aware of. But so I went to GitHub, and this is before OpenAI listed their favorite Java wrapper, and I found this one developer, Little Cat, or little cat on GitHub. So you could search for that person. It was tough for me to read some of the code because not all of it was in English. So I had a difficult time doing it, but it was very, very simple. It was very, very simple. So I wrote this little, one pager to another poor man's ChatGPT. So you get a command to the command line. I get the stuff from the user and I send it to this library and ask, and I get the result. And I get rid of that \n for some reason that they put in the front of every line. So I do that. And there's a poor man's ChatGPT. Okay. And then I finally on OpenAI, they listed a Java API that was their favorite. So they listed, I didn't check today, but I think as far as I know, this was the one that they recommend. So I took a look at this gentleman, Theo Canning. His API is it's more complete. It covers all of the APIs that OpenAI has. So back to this other gentleman, he has an API, but it only covered partially the API set. So it wasn't complete. So I said, yeah, it's a nice, simple API, but I need to use everything. I want to have complete access to all the underlying parameters for their API. So it's a little more complicated. You have to create this thing called a chat message, and there's something called a chat completion request. I mean, it's not that complicated. It's just more complicated than the other API. But he covers the entire set of functions that OpenAI has to offer. So I'm going to stick with this until something better comes along. So if you go to GitHub, just search for Theo Canning .openai. And I had a friend of mine in the NYJavaSIG, Rodrigo Graciano, fellow Java champion. I asked him to create a Spring Boot version of my code, and it took him like 20 minutes. And he created a little Spring Boot app that basically did the same thing, but over the web. So it's pretty easy to do. So this is now accessible to all Java developers. So you can now call ChatGPT through an API in the back end from Spring Boot. And if you do a Spring Boot, you can do it in a lot of other frameworks too. So that's how you use it. I'll use the API. It's pretty straightforward. Okay, now, how do I use ChatGPT to code? So I asked it, write a Java program that displays hello world, right? So I'm asking it to give me some code. So this is what I got back, right? So let me go back here. So I said, here's a simple curl script, and I'm using the GPT 3.5, and here's my message. And the role is a user. In other words, that's me. I'll talk about user in a second, but the content, the actual prompt is, give me a Java program that says hello world. And it gave me back some JSON, right? But then here's the actual result. And it says the usual thing. It says, I can't write programs, blah, 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 but here's a program. And so it gives me a Java program oh, if I didn't pretty print it, but it's a Java program that says hello world. So it can generate code. So what if you had this, somebody, your manager comes over to you and he or she says, like, I have a bunch of PDFs, right? And they're all in a directory, they're in a folder. And I need a program, a Java program that reads all this, gets all the text out of each file and puts that text in a new file. And I want each new file to have the same name as the PDF, but I want like a sequence number. How long did that take you to build? Anybody? How long did it take you to do? I don't know, a couple hours maybe? Okay. Probably would take a couple hours. So I typed this into ChatGPT and I got that in 10 seconds. And I said, well, give me another version. It gave me that in 10 seconds. Now, is it right? Well, I have to go through it. I mean, but it gave me something to start with. I'm not assuming it's right. Matter of fact, I'm not going to compile it and run it without looking at it. I mean, if you do that, you get what you deserve. And you, first of all, should read the code and make sure it's doing the right thing. But it's pretty close, right? Pretty darn close to what you would do. And we're talking about like less than 30 seconds. It created 2 different versions. So when I did that, I was, okay, that's interesting. I mean, I still have to look at it. I still have to check it, but it gave me a starting point. This is like going, to ask, to someplace on the web and asking questions of your colleagues. How do I do this? How do I go into /data? Like, how do I do that? How do I do that? Well, this is doing exactly that, but it's giving you the information like in seconds. So that's really interesting. So it's all about creating this thing called a prompt. Now, here are some interesting other prompts that you can type in, like create a table, and you could say create an HTML table, or create some other table with the 10 most populous cities with the city name, population, the leader, and give me the JSON equivalent. If you copy paste that into ChatGPT, you'll get that answer in like seconds. Here's another one. I want you to act like a Linux terminal, and it's giving you information to be very explicit. This is like, you have to be a logician here. They'd be like, you're talking to Spock or a robot, which you actually are talking to a robot. Give it details, and it says, I want you to behave like a Linux terminal. And interpret spaces, new line. The new lines would be this, and the distribution is a specific Linux distribution. And here's my command. What does it give me? And if you do that, you get exactly what a Linux distribution would if you did cat etc os release. So that's like, wow, that is really, really cool, because it's been trained on that, right? And you say, well, what does this sed command do? What does this regular expression do? I mean, how many times like you see something in someone's code is like, I have no idea what this is doing. It's some regex that's beyond, that's from another planet. So I asked ChatGPT, what does it do? And it'll tell you step by step. Oh, it's doing this, this, and this. So it's like it's like pair programming, right? With someone like that's pretty knowledgeable, not perfect, but pretty knowledgeable, right? And here's another one. Like I haven't done Java FX in a while, so I said, like, give me a Java X app that did this. There's a text area there, and there's a button here, and there's a blue button here, there's a red button there, and I want you to contact a ChatGPT server with this API, and when it comes back, put the text coming back into this field. And it gave me a bona fide Java FX application. And we're talking about in seconds. So prompt engineering, and if you've heard that term before, it's about designing text that it's a language that you talk to this robot, this language model, this LLM. You want to get information because it's not a search tool. It's a language tool. It knows about language probabilities, and it knows about language architecture. And you give it a prompt. In other words, you're prompting it. Here's what I want. Here's a context. Here are some possible questions you might be asking. Here's some possible answers. And here's a new question. So with that information, give me a completed set of text. Right, here's a prompt, give me a completion. So again, prompts vary from model to model, so be careful of that. And like any new innovation, like for a while there, we got all inundated with ChatGPT and all kinds of tools, and like, this is cool. Look at it. If you try ChatGPT, or did you try Bard? Did you try Anthropic? Did you try Cohere? There's all this cool stuff. But that was like months ago, right? So what happens when a new innovation comes out and we get something like large language models and generative AI? There's the initial buzz, right? And then the developers step back and say, you know what? We can build a whole bunch of tools to help people with this. So now we're in that phase. We're in this phase where people are building tools to do even further prompt engineering to help you. So there's already a whole set of prompt engineering tools, and there's even more. And they may even be language-based tools themselves, and they may be collections of LLMs. So we're in that phase right now where there's a lot of the tool builders are in place. So when you play around with OpenAI, with the ChatGPT, I mean, everybody goes to the app, right, to the web app, to chat.openai.com. But that's the web app. That's what the average person goes to. So we're developers, right? So we go to the playground. So OpenAI is a playground. Google has, Bard, they have a playground. Anthropic has a playground. So what a playground does, it gives you access to the API through the web. So this is the playground, and I asked it, why should I learn Java? And there's like system, user, and assistant, and there's a bunch of parameters on the right hand side. These are parameters that you send as part of your REST request. Something like maximum length, how many words, actually, how many tokens, this is essentially words. How many words do you want the result? And if it's, you might want 1,000, or you might want 4,000 or less, you want to restrict it. Temperature, I'm trying to figure out why the history of the word temperature, but do you want it to be creative or not so creative? That's what temperature really is. So the higher the temperature, the less creative it is. And when you say that, what it's really doing, it's increasing the amount of randomness in picking the next word, right? If it picks the same, be very consistent. So it's going to look at its probabilities and not be too random. But if you lower it, increase and make it more random, it's sort of like, quote unquote, becomes more creative. It just becomes more random. I'm quite sure why they call it temperature, though. But notice those three things. So when you talk to ChatGPT, there's three roles. Either it's you, the user, right? Or it's ChatGPT itself, that's the assistant. And then there's system messages. So when you use the web app, chat.openai.com, the system message is that you are a helpful assistant. That's a default. That is the default system message. You can change that. You can say you are a totally unhelpful manager. That's been a pain in the neck for me for decades. That's how I want you to answer. But that's a default system message sent through ChatGPT. You are a helpful assistant. And this is what you get back. So use the playground. We want to use ChatGPT, and same thing with any other tool like the Anthropic or Bard or Cohere. Go to their playground, because that's how you use their REST API, but it's through a web interface. Any other questions? Okay. All right. So then the structure of a prompt is that it's, when you first, like something that's a real simple thing, like, why should I learn Java? That's not really, that's called a zero shot prompt. In other words, I didn't give you any examples. I didn't give you any context. I didn't give you anything. I just said, why should I learn Java? And I want you to complete that prompt. So that's a zero shot prompt. But really, in a production sense, you need to have a prompt that gives you context. Like, I want you to respond as if you're a teacher that's teaching third grade students. I want you to behave like a college professor that's talking to a group of graduate students. So that's the context. You give it some examples, right? Remember, it's a text tool. Give it some examples of some prompts and some completions. Like, here's a question and here's an answer. Here's a question, here's an answer. Here's a question and answer. So that's sort of like some ideas. You're sort of tweaking the model. Here's my actual question. And you're saying like, give it to me in 3 sentences or 3-sentence summary, or give me it into an HTML table, or give me it in JSON, right? So this sort of like the structure of prompt. Now, you don't have to have all the sections, but that's the basic structure of prompt. But it's only one way of programming ChatGPT. So there's 3 ways. We talked about prompt engineering, right? It is a structure of a prompt. And the average person comes up with like a short question. It's like, well, that's called a 0-shot prompt. It could answer you decently, but it's a language-based thing. So you have to give it context. You have to sort of like guide it. You have to guide the language tool and with some things and tell it how to respond. And then there's these 2 other things which are really cool. So prompt engineering is the more straightforward thing. There's embeddings and fine tuning. Okay, I see a question in the chat. Does order matter to prompt? No, it does not. That's a good question, Linda. It does not. It does not matter. Which is pretty interesting. I mean, the way they parse that, but it doesn't matter. So prompt engineering, there's something called embeddings. Now, embeddings are, okay, what is an embedding? So an embedding is a vector, right? It's like an array in Java, and it's an array of floating point numbers. And it tells you how one thing is related to another. So let's say like you have a music collection, right? You have different songs. Well, how are the songs related? Well, you can say like, well, so let's say I have a Metallica song, and well, okay, that's hard rock, and then it's a heavy beat, and there's a strong bass, and so it has parameters, right? But then actually, there's some jazz songs. I like Miles Davis. It's like, well, this doesn't have a heavy beat, it's a slow beat. The tempo is not this; it's lower. It has less notes. So there's like parameters. You might come up with 3 or 4 or 5 or 6. And then as you add more songs, it's like, actually I need more variables. And so you might eventually have, 20, 30 parameters. That's pretty simple. But the way you store those parameters is in a vector, because obviously machines deal with numbers pretty well, right? So you have an array of floating point numbers, but when you look at the numbers, you can now compare them numerically. So you can compare Miles Davis to Metallica numerically, and you could say, are they related? And it's like, actually, they're not so related. But I may have a jazz. I'm drawing a blank on jazz. Thousands of jazz developers. I can't come up with a jazz performer. But if you have 2 jazz players, and you say like Miles Davis and Art Blakely, and like actually they're kind of similar, right? So I should put them all in that category. So embeddings are how things are related. So if you wanted to, you have like, let's say your company has documentation and you want to have a nice chat interface so people can ask questions of the content as opposed to looking up things, right? And so what you do is that you take your existing documents, you break them up into sections, right? It could be on paragraphs or on an HTML. It might be what, H1, H2 labels. So you come up with embedding vectors for those words, and you store that in a database. So you might use all databases can handle vectors these days. If they don't now, they will in a few days. It's every database has to have that. So you have database of your embeddings, and then you ask a user for a question, and they ask a question of your docs, and they come up with a question. You create an embedding for that thing, for the user. Then you take that vector and you compare it to what's in your database, and you find the most closely related ones. It goes, oh, here's the top 3, and then show that to the user. So that's one way of doing it. As a matter of fact, I was going to work on a blog post on how to do that in Java. So you're not changing the model. You're using existing, for example, ChatGPT, using the existing ChatGPT model, but you're building a collection of embeddings and then sitting on top of that. So prompt engineering and embeddings are sitting on top of their foundational model. You don't change the model. Now, fine tuning is a little more in depth, is where you're actually changing the model, or actually you're modifying the model. Okay, so you're the foundational text model that they have, and you're adding a layer around that for specific purposes. So you're actually modifying the model. Where prompt engineering embeddings, you're not changing the model. So it's pretty straightforward. You're not affecting how the model behaves. You're just sort of guiding it. You're guiding it in a certain way. Fine tuning is where you're actually creating a new model. So it is more in-depth work. There's more data involved. So if you're working on a project for like the medical field, specific aspect of the medical field, or a specific aspect of legal or finance, where there's a lot of data and it has to be looked at carefully. And so that may be a place for fine tuning. So you have to just pick which direction you want to go in. I mean, you can get quite far with prompt engineering, right? Of using your structuring your prompt. Embeddings, it would be the next thing. Like that would be useful if you have your own company's documentation. You want to create a chat interface to it. I mean, everybody's creating chat interfaces. This is sort of like that's the craze right now, is creating chat interfaces. I mean, probably in a year from now, people will be creating something else beyond chat interfaces, but that's what everybody wants to do now. And it's helpful, right? It's like, frequently asked questions. Like I can now have, an interface to frequently asked questions, as opposed to looking up a certain question. The language model will help me answer that. Whoops, I see a question here. Are embeddings a form of guardrails for hallucinations? Okay, very good question. So hallucinations, right? So hallucinations are basically bad completions. So we know what a completion is, right? We sort of guide the engine that I want you to here's a context, here's what I want, here's some examples, and now take over, and here's what I want. So you're guiding it. But if the completion is not a good completion, it goes off in a different direction. Like I might say, like, who is Frank Greco? When it goes off, and Frank Greco was, somebody else. It's based upon probabilities. That's called a hallucination. It's politely called hallucination. It really should be called a mistake, right? But it's a hallucination, and it's getting better and better. But with embeddings and also with fine tuning, let's go back to that slide. With embeddings and fine tuning, you're entirely right. You're entirely right. That's how you not prevent, but as you're saying, put guardrails. So if I was doing this for real, I would have the embeddings database, and I'd have the user ask questions. But in development, I would have test users ask questions, and I would look at the result, what came back, and then I would use that information and feed it back into the embeddings database to correct it. So it doesn't change that part of the workflow. You get answers back from the user, and if they're wrong, you correct that in your embeddings database. So over time, it gets better and better and better. And then the same thing with fine tuning. You just can't create a model or create a set of embeddings and say, "Okay, I'm done." No, you have to test. Well, we all know that. We're all Java developers. You have to test. You have to test what you create. So that's a very good question. Okay, so then what is the fastest programming language for 2023? It's English. Actually, it's human language. It's not just necessarily English. But it's text. So if you're a programmer, you have to know about these tools. Because if you don't, someone else is going to know about it, and they're going to compete with you. So you have to be quite aware of that. And this thing now that I'm on my last slide, I finally figure out how to get rid of this pop-up. This is very important. They don't improve the quality of your productivity. They just improve the velocity. Right? They only improve the velocity of productivity. But you have to be aware of these tools. The world has changed. The world has completely changed. You have to learn about these tools. This is going to affect, not programming, it's going to affect everything we do. It affects everything we do. So, and here's my last slide. What's coming after this? Okay, so you're going to be learning, instead of pair programming with a human, you could be pair programming with a large language model, right? And there's all kinds of tools coming from prompt engineers, for prompt engineers. So there's a lot of stuff there. ChatGPT runs in the cloud, right? And so does these other tools. But now, since transformer architecture uses parallelism, and we know that Java with like things like Loom have many threads, you can actually do this stuff on a desktop. So we're already seeing like versions of LLMs that run in your desktop and give you the same performance as ChatGPT. And here's another one, machine learning for systems. So there's now work, there's actually now conferences on using machine learning for low-level operating systems, because they've discovered that for data access. So instead of using like good old-fashioned data access, like how databases access data on a disk or in memory, or how the operating system accesses data structures in the kernel, what if we use machine learning for that? And it turns out that they're getting significant performance by looking at patterns. So this is a long-term thing, but I mean, this is a cool time to be in computer science. I mean, people are saying like, oh, it's going to destroy programmers. You're not going to be able to program anymore, and we don't need us anymore. It's the opposite. This is like the golden era for us. There's so many places where machine learning can be used, and for programmers, it's just mind-boggling. So there's a lot of stuff. There's also the bad side. We talked about hallucinations. There's legal aspects. You know, that people are. I think I saw recently the actress Sarah Silverman is now suing, along with a bunch of actors, suing OpenAI for copying their book, their text, and then repurposing without giving them any money. So there's all kinds of legal issues. Creating spam just became 1,000 times easier. So there's a lot of cool things, but it's an interesting era in our lifetimes where we're in a major league discontinuity. I mean, normally in someone's career, you live through one, maybe two of these things in your career. I mean, I've been really lucky. This is like the third one in my lifetime. This is probably the biggest one. So it just to me, it's super fascinating, and because it has ramifications beyond just the language, it has countrywide. I mean, it is like planet-wide implications. So it's just fascinating. The best free alternatives to Copilot. Actually, it's a good question. I don't know offhand. I heard about some free alternatives, but actually a colleague was mentioned, but I can't remember the name offhand. But I'll try to find them and I'll send them to the user group, and then you can get them from somebody that made from Bruce. But that's my last slide. So I appreciate it. Thank you very much. Again, this is a cool thing, and please learn it. Please learn it.
Okay, does anyone else have any more questions for Frank? You can put those in the chat box.
Mary. So Mary's question is that would it be fair to say there would be more jobs for humans to perform QA and testing? Yes, and for sure. I was actually joking with my manager today about that same problem, about how you have to QA the results that come back, just like we did for conventional programming. So that's not going to go away anytime soon. That's definitely true. When you give a response on BARD, this is from Linda. So so Linda's asking, when you give a thumbs up, thumbs down, how's that being used? That's just telling it's embedding, it's changing the embedding. So what an LLM is really, it's a giant database of embeddings. That's all it is. And it's a database that stores a bunch of vectors. So what you're doing is that you're changing how those embedding numbers in the embeddings. And OpenAI and other companies, I mean, that's a painstaking job to do that. So they hire a lot of cheap labor to do that. So you're helping them by doing thumbs up and thumbs down. You're changing an embedding, because that's what an LLM is. It's a giant database of embeddings. Where do you recommend we start? So if you're a Java developer, which I hope you are, I would suggest trying, first of all, get an account on OpenAI. Just go there and register for an account, and then it gives you the ability to create a key, an API key. I mean, it takes you 24 hours, I think, to get the account, and then after you just log in and you create an account, and you just create a little. First of all, what I did, create a little curl script just to see how it works. Once you get that, and then change it to a Java program, then change it to a Java FX program, or maybe put it on the server. So just, take it one step at a time. But first of all, just get an account and just to play around with the playground. Right? IP generation for patents. You mean like has patent lookup? I think that's what you mean, right? For patents. So you probably heard the story, I think it was in the New York Times, that a lawyer, a very misguided lawyer, during his court case, decided to use ChatGPT, and they gave all the information that ChatGPT came out with to the judge and to the other lawyer, his opponent, and none of it was true. So it's quite embarrassing, because it was not trained. You can't use ChatGPT like that. You can't use, it's not a search tool. It's a language tool. This is why the average person, or person that's not an IT person, doesn't understand. It's not a search tool. It's a language completion tool. It understands patterns and wants you to, and will complete it for you. That's the tool it is. It's not a search tool. It's not going to get information. If someone, look, it told me this. It's a language pattern tool. TJ Kelly says, I used a prompt. Yeah, exactly right. You can tell it how to act. Like you're saying act as an editor. That's context. That's part of your prompt. So act like this. And like I do a lot of training for college students, and the response can be act as if you're teaching graduate students. You're a college professor teaching graduate students, or explain this as if you explain to a third grader, and it will change the way it describes it. Mary says, how about leveraging event streaming? Event streaming to perform real-time data ingestion to the model. That is a startup idea, Mary. Contact me later. So OpenAI has information up until September 21st. So that's all it knows about the world. But there are now other systems that are trying to do this more real time. It's an ongoing area of research, Mary, how to do this in real time, because you're constantly updating a model, and updating models. So this is, as a machine learning developer in a big company, you create a model and you put it in production. And of course, then there's version 2 comes out, and then you have to put version 2 in production. Then there's version 3, and there's version 4. So there's all kinds of, we know as Java developers in an enterprise, there's all kinds of stuff you have to do when you update something. That doesn't change. So updating models, we're talking about new areas. So if you wanted to be an expert in this area, and you know a lot about deployment, learn about models and how you should update models and evolve, model evolution. That is an ongoing discussion for big enterprises. How do we evolve models? How do we migrate models? How do we take it from over here and there? How do we version 1, version 2, version 3? This is a big problem for enterprises, and it's an ongoing issue. Can we use ChatGPT to create new intellectual property? That's an idea. So create new IP based upon what's out there. You could. I would say that you probably have to do a little more work on either embeddings or with fine tuning, because it's based upon Google patent database, again, for language, right? So you're looking for patterns there, but you may have to tweak it a bit for that. So that may be a fine-tuned model. So I doubt that prompt engineering would give you that, but prompt engineering can give you quite a bit. ChatGPT acts as a teacher and student. Yeah, so you can. So there are some people that have two instances talking to one another. That was actually pretty fascinating. But yeah, I think that's the last question. But it's a cool area, and it's going to be with us for, we're talking like a long time. This is not like a year, 2 year. We're talking about like 10, 15, 20 year, and there's many aspects of this. So it's not just for, programmers, and maybe if you're interested in geopolitics, if you're interested in how to use it for medicine, how to use this for systems programming, there's so many aspects of machine learning. It's phenomenal. How ChatGPT predicts stock market data. There are many, I've read many articles on people that have used ChatGPT to attempt, and Wall Street has been trying to do this for decades. So it's hard to predict the stock market, the equity market. It's very, very difficult. You can come with a basic idea, but it hasn't been done in decades. Maybe it's possible, but I've read articles where people they've had like 20 models going on at the same time, looking at all kinds of parameters, and they can get within an epsilon of accuracy, but it costs a lot of money with all these different models and systems. Yes, statistical analysis, that's been done for like decades, right? So, I mean, stats has been with us more than a few decades. It's been like for a long time, right? And machine learning is statistical analysis plus. There's more things to it. Any thoughts on of Sydney? That it's that it's alive. So that's alive, or it's convinced me to leave my wife. Well, if you think that a piece of software is going to convince you to leave your wife, you have other problems to worry about. And saying it's alive. It's a language tool. It's just looking at patterns and telling you that I'm going to complete your text, what you told me to prompt me, and I'm going to complete it based upon probabilities. Is that intelligent? Oh, I don't think so. Yeah, it's mostly hype. So, and the same thing with artificial general intelligence. It's going to take over the world. Yes, there are certain dangers because the average person is not that smart, and they watch some of these answers and they believe it. So we're the smart ones. We understand what it is, but the world is, we're a tiny sliver of the world population. I mean, tiny. We're the programmers, but we're minuscule. The average person does this stuff and they think it's alive. We're talking about something that's psychology, not computer science. So yeah, it's certainly not alive. It's certainly not, and people saying that it has reasoning. We may discover that it's doing something that we don't understand. I mean, some of the transformer architects and some of the senior people are saying that we actually don't understand how it works internally, which scares me a bit. I mean, it scares me a bit because back in 2008, during the financial crisis, we had derivatives, and we used to ask the Wall Street people, so how did these derivatives work? We actually don't know. And look what happened. So, and there's a pattern, right? So I worry about that sometimes, but to me, it's mostly hype. There needs to be guardrails because the average person's not smart and they'll use the information in a bad way. But there's a lot of opportunity. There's a lot of opportunity for people like us. So I hope you, whatever, if you take just one little thing from this, just learn as much as you can about this stuff, because it's going to be every part of your lives. Oh, there's one more question from VJ. How are companies developing their own chat GPT-like systems for For example, JP announced something recently. Well, to me, there's these large language models used for the public, but I think where the money is enterprise use of large language models. And so when you type something into ChatGPT or Bard or Anthropic or any of these other systems, that information, and if you don't look at your profile and you keep it open, that information gets sent to their servers. And it's stored in their servers. And it's created an embedding. And so that's why the Samsung engineers were using ChatGPT, and they didn't turn off the privacy. They didn't turn on their private data. So they were talking about things that we're working on that were not released yet. All that information went to ChatGPT. So you have to be careful when you talk about that. Now, of course, the enterprise, they don't want that. They want their own instance. So if you go to like Microsoft and Azure, you can have your own private instance of ChatGPT. And if you're a company, that's what you want, right? And the same thing with Bard. You want your own private instance. You don't want to leave the premises. So to me, where the money is going to be is an enterprise use of this stuff, not so much on the public. I mean, there'll be a lot of fun stuff with the public, but for a lot of us that work for big companies, that's where a lot of the work's going to be. Building an LLM from scratch is hard. It's not easy. So I doubt that they built it from scratch. I mean, they're what's the company? Cohere. So COHERE.ai. So Cohere, their goal is to create LLM tools and tooling for the enterprise. So security, privacy, regulations, governance, all the good stuff that we all don't like, what we have to deal with. But that's their specialty. Any other questions?
Okay, well, if that's all the questions, then I think we'll probably end the recording here, and then we'll go into the raffle here. So usually if we're in person, we have a big round of applause here for our speaker and everything. So I guess we'll just kind of do that that virtually. Oh, looks like one just came in. What was that? Indicated the big four accounting firms are spending over $300 each year to figure out where to go with this. I don't know.
Yeah, it's a cool time to be here. It's like the people are paying us to learn this stuff. It's cool.
All right. Well, thank you very much, Frank.
You're quite welcome. My pleasure.